Hey everyone, I want to address something that's been bothering me in my studies is trying to look at a Hayworth projection of a sugar and determine whether or not they're alpha, beta, or D or L. And I came up with a way through reading that I think is makes this kind of easy. And first thing that we're going to do is look at the sugar, and we're going to identify the anomeric carbon. And if you don't remember what an anomeric carbon is, the anomeric carbon is attached to two oxygens. So let's find the anomeric carbon. We look through and we see that this carbon right here, this one is our anomeric carbon, as it's attached to two oxygens. And this is where we start our numbering of the ring. So this is 1, 2, 3, 4, carbon 5, and carbon 6. This one is your acyclic carbon. Okay, so now the first thing that we want to do is look at our anomeric carbon and then look at the substituent coming off of the anomeric carbon here and compare it to your acyclic substituent here. So if this relationship is trans, this will be an alpha sugar. If this relationship is cis, this will be a beta sugar. So we can see that this first one, the first group, is going below the ring, and the second one above is going above the ring. So this is a trans relationship, meaning this is going to be an alpha sugar. So let's put that over here to the side. This is going to be an alpha sugar. Alpha sugar, because it is trans. Then the next thing you want to do is imagine yourself as the anomeric carbon. I am the anomeric carbon, and you're looking down your ring. And if the acyclic group over here is to the right of the line that you're looking down, if it's to your right as the carbon, this is going to be a D sugar. If it's to the left, it's going to be L sugar. So this one is going to be D because it's on the right. So because right as carbon looks. So if you're the carbon, the anomeric carbon, and you are looking down that direction, if it's on the right, it is a D. And then this sugar is then alpha D glucopyranose. Okay, let's try another one. Do a couple. Alright, so first thing we want to do is determine where the anomeric carbon is. In this case, the anomeric carbon is here. We circle our two substituents that we're concerned with, this one, and then we look for the acyclic group here. And in this case, you can see that the first one, this one is above the ring, and this one is also above the ring, so they have a cis relationship. Remember, if they are trans, it's going to be an alpha sugar. If they are cis, it's going to be a beta sugar. So this one is a beta sugar because they are cis. Okay, now next we're going to imagine ourselves as the anomeric carbon. We're looking down the ring, looking down our ring, and this is the right side, this is the left side, and our group up here falls on the right side, so this is going to be a D sugar as well. D because it's on the right. So this sugar then is beta D glucopyranose. And the pyrans, if you remember, these are 6-membered rings, 6-membered. And if it were a 5-membered ring, do you remember what that is? If it's a 5-membered ring, it's going to be a furan. So if this were a 5-membered ring, it would be a furanose. It's a 6-membered ring, it's going to be a pyranose. So this sugar, the name for it, is going to be beta D glucopyranose. Okay, let's try one more. So here we have our anomeric carbon. First thing, anomeric carbon. Then we number that 1, 2, 3, 4, 5, 6. And now we take a look again and we say, is this substituent cis or trans to this substituent? And you can see that the anomeric substituent, the OH group, is above the ring, above. And this acyclic group right here, coming off the acyclic carbon, is below. So these have a trans relationship. And a trans relationship means that they are going to be alpha, right? Is that what we said? Alpha is trans. So we go back and we say this is alpha sugar because they are trans to each other. Then the next thing we do is imagine ourselves as the carbon. So we are the anomeric carbon, and we're now looking, taking a peek down the ring. And if we are standing there at the carbon, this would be the right side, this would be the left side. This group falls on the left side, so this is then going to be an L sugar. L sugar. So the name for this would be alpha L glucopyranose. I don't know if this works for everything, but it sure helps with me here. So thanks, good luck.